Hi, welcome to the introduction of iRAD. In this presentation, we'll have a brief presentation on the background of how iRAD came into being and what is the implementation planning that we have. This is Venkatesh Balasubramanian. I'm a professor in the RBG Labs at IIT Madras. At RBG Labs, we've always worked towards picking up societal demands and then try to bring about enhancement in quality and productivity of people, process, and products. The way we go about is having a design thinking approach to problem solving so that we can have some kind of a good disruptive innovations and lean operations that can be brought into the picture. Area that we have worked largely are in medical devices and implants, where we have developed some new products and processes and taken them to the logical conclusion of to the patients. The other area that we've worked towards is transportation safety. Between these two, we all try to take it towards public policy initiatives wherein we could apply our gap analysis and the tools that we have developed. We're using the tools we developed and bring about changes by working very closely with nodal agencies in the government. In the transportation safety, we've worked largely towards understanding the driver and what he does in terms of behavior, performance, health, and so that we can have a good occupant safety. What we developed as some of the technologies, we pushed those technologies, transferred them to Harita seating systems, and a product that can measure the presence, posture, and fatigue ubiquitously without being in contact was launched. The Harita Intelli seat was launched in April 2017. Video of it could be seen here. After its launch, it won the Auto Component of the Year in India, and hopefully it can go towards a good amount of road safety. While we do a lot of research, we try to continue to monitor driver fatigue, their health, their behavior, and offer it as a training that we can do to help the system. But something that irked us a lot is what we do find is the number of people killed in the road at all time. As you can see, the number of 150,000 plus people being killed on an average on the Indian roads is a serious cause for concern. As drawing inspiration from Gandhi, Gandhiji's quote of, the future always depends on what we do in the present. So we decided what could be done in the present should be done by us. So what we do know is to have a systems approach and wanted to develop a framework by which the systems approach could be brought into the picture. So we went to build RBG Labs Transportation Safety Framework. Two premises based on which this framework was built. The first one is to understand the chronology and the participants who will be involved in this event called accident, and who has a highest impact in terms of the interventions that could be brought about. While the accident zone can be split into what happens before the accident, what happens during or just before, just after the accidents, a little before, little after the accident, what happens, and then what happens subsequently after the accident, what we go about doing it. In terms of the pre-accident, there are many government departments which are marked in green. The darker the green, the higher the level of work that they could do. And other participants who are in the user group, so to speak, in terms of the vehicle manufacturers and the citizens that are there, all of them work towards decrease in occurrence of accidents. What happens in the peri and post zone, we feel can actually increase the survival rate of the accidents. So one of the first premise that we say we had is while very smart minds, extraordinarily brilliant people work very tirelessly towards reducing the occurrence of accidents. We figured that one of the things from a public policy point of view where we can have a bigger impact is what if we increase the survival rate using engineering concepts, lean concepts in the whole process. So that is the first premise into it. The second premise is, while the 4E concept, which is popularized by Ministry of Road Transport, was a very elegant one, we believe there was the missing link in this 4E, the fifth E that was there in everything that was constructed from a policy perspective. The fifth E, or the empathy that is there, comes also from our interest in human factors, should be the link that actually brings all these things into play. And in the second premise, the sub-premise that we had, we wanted to do is at the thought level and what is at the ground level. Enhancing emergency care and the engineering to decrease the accident and increase the survival of the people who may be involved in the accident was critical. At the thought level, enforcement and education is critical. Again, we believe enforcement should be at a thought level rather than at the ground level, for a very simple reason that uh, a deterrence is only going to work for the undetermined people. So the determined people will anyway do, that's the ground deterrence that should be there. But if you have a deterrence in terms of enforcement of the certainty of things to be caught, it should be there at the top level, and education should probably have a bearing onto it. So this is a sub workflow that we thought should happen as we go about. Using this philosophy, we built the transportation safety framework, which revolves around having a good trauma care system. In Tamil Nadu, we called it THAI, which takes very high quality of data, works on making sure that the stakeholders understand what they exactly are doing so that they could be trained. Good trauma care centers, which are cost effective, because trauma care centers most of the time should probably be inactive, but still be viable in the system, within the ecosystem in which we all operate. So this is from a trauma care system that we thought. To go about getting good quality of data collection, very critical was to understand why quality of data is probably shaky, uh, and what could be done to address the way by which this data collection can be enhanced and the quality of data be improved. We believe that the one that is missing is the structured reporting, and the reporting should translate into intervention. So how do we go about doing it is to build a good transportation accident registry system that we could do. Again, from a vehicle engineering point of view, we could have more and more sophisticated systems that are there, that are built, driver or driverless vehicles, and so on. And the idea of it is to create a mechanism by which we have a good uh, mechanism by which driver behavior, performance, and other thing is monitored in spite of what we did. How do we bring a penetration of it? How can it be ubiquitous and within the vehicle so that it can be used as a training tool, as intervention? Working with the vehicle manufacturers, to use this data not only for an accident analysis but also as an education tool for improving the driver behavior and performance and training, whatever we would want to have. Similarly, for the infrastructure, we could have a good mechanism by which a good data registry in terms of this, in terms of the road structure assessment and the traffic management could be enhanced so that that system could work very well. Again, this is the crux of the work that we wanted to do. But remember, we started with a motivation of very high accident, and the city that we live in, Chennai, is in TN, where we have about 17,218 accidents in 2016, a baseline year that we picked. And that was the second highest fatality in India. So we said we should have lofty goals, very visionary goals, should achieve it. This thing, one is a necessary goal, which is there as an SDG goal, about 50% reduction in the RTA deaths. Second is to go ambitious and say how can we avoid bring it to 0% death from crashes. Accidents, we will take it slightly away, and the crashes that happen, that could be addressed, and we could have zero fatality in the process. And we develop comprehensive systems that are there. So all these things can work if we have good intermediary outcome measures that are set, and that could be measurable, palpable systems that are there. So we were using a lean framework in soil management system, the design thinking and the problem solving tool, the RIP, and also the expertise of the domain that are there. So working with the Tamil Nadu government, it's a good success story that we had with various agencies in Tamil Nadu government. Did terrific job after our black lettered year in 2016, where we had the highest amount of fatality, 17,218. Our RBG Labs intervention started somewhere in the middle of 2017, and as we progressed in that year, we could bring about 6% change by going after our survival, increasing the survivability. By year 2 in 2018, we could have a significant amount of drop as at about 25%. This is when the Ministry of Road Transport declared it as the TN model for road safety. What happened, and there was a curiosity that came, and it was not a one-time wonder. It dropped by another about 14% in year 2019. That's about 78% of SDG goal. 2020 is a black swan year, so we can definitely reach the SDG goal, but the idea is whether 2021 will be less. So what exactly happened in this TN model? TN model was all about being a data-driven intervention that could be made. There was always a data collection, data collation, and analysis. I will tell you about where the data was collected and how this data was used in the subsequent slides. What happened with the police is to build a resource planning which was better. Good black spot analyses were made. Good location analysis were done, so that accidents were addressed in a very systematic way. Our health department worked very diligently doing a grid analysis of the accidents information that was collected by the police, so that the assets were located, the assets in terms of the ambulances, trauma care centers where we would want to put the human resources that are to be there. So we could locate assets to areas which are more prone to accident at the times that are more prone to accident, so that the lift and the care given could be well. So that allowed for better resource planning to have a good impact. Highways, of course, use the data that was collected to form the black spot rectification, planning, and budgeting. From the health department, as you would have seen, there was a spectrum in which the Tamil Nadu Accident and Emergency Care Initiative, TAI, that was built to cover end-to-end from peri-accident to deep rehabilitation post-accident, using lean concepts and lean manufacturing concepts into how emergency care could be delivered. The data collection process revolves around, not from here, but by 2009, Tamil Nadu had started a program called Road Accident Database Management System. This RADMS was a very good mechanism by which you keep collecting all the data that is required. This system was very effective with the enforcement agency, police, collecting good quality of accident details and a reasonably good quality of collision details. Obviously, cops are not experts in everything, so it was very iffy with other aspects that were required in terms of environmental details and witness recordings and other aspects that are there. This allowed, and the impact of the change in the state allowed the police to start asking a question: what could be there? There were good analyses which were coming and which were trying to give some input, but in the analysis of the RADMS, the key things that were expected to be improved was the comprehensive and structured accident data collection that was required. You have to de-skill the data collection operations, because the constable or the person who is going to be at this accident site is not going to be a very good expert in traffic investigation. A traffic investigation officer is going to turn up at the accident site much later, but before then, the scene is going to be disturbed. So you can't get the skilled person at the work site at the time of your choosing. So if you de-skill the process, the data collection should be good so that the skilled person can work on it later. So that's one of the suggestions that was pushed by RBG Labs to the Tamil Nadu police. And the next one was to understand and appreciate the key role of the traffic inspector or the investigation officer who was doing this, is that he was forming an opinion, or what is called as the IO, investigation officer, is forming an opinion, which is also called as an FIR. Now the fact has to be collected, and one has to distinguish between a fact and the opinion that is being formed. So how do we enhance the fact collection so that various aspects of the facts are pouring in from various departments that are there, or people who would be expert or domain experts, so that it can be pulled together by the IO so that he can form a very good opinion onto what the accident is. So with that process, transportation accident reporting app TARA was developed, and the concept was shared with the Ministry of Road Transport and Highways. In fact, this is a meeting in which the DGP and many more ADGPs from the state of TN were participating to share the knowledge of what we had brought about to disrupt the road accident collection. And we also worked with other states in terms of taking the conceptual idea forward. So Marth acknowledged the relevance of TARA and how it could bring about a change in the accident database collection, or the philosophy based on which this TARA was built, and accepted the TARA even at the pilot stage when it was being implemented in TN to be accepted for pan-India deployment. The iRAD was a very comprehensive program. Integrated road accident database system would be a very comprehensive program. It was not just collecting data. Of course, collecting data with data integrity was very important. But what was learned from TN is how do you analyze the data so that you can develop interventions from these data. And once you develop an intervention, how can you effectively implement it in an integrated approach? It is not like one department is doing one approach, or distributed, a lot of people are doing a lot of approach, but we probably may not see an impact. Of course, there are a lot of small impactful work that could be done, but how can we have an integrated perception of different agencies trying to bring about a change in implementation? So this is a sum total of where iRAD was heading, is to collect data with integrity, develop interventions by deep analysis, and have an integrated approach to implementation. To do all these things is a jump on both the skill and the complexity scale of the process to a very huge extent. So a roadmap for it in a sequential process, some sequential and some parallel, was built. The roadmap was to initially get a few states involved to understand the quest for resource prioritization and make road safety as an issue that needs to be addressed on a priority basis. So interacting with the states to bring them on to a common platform in which we could develop a common solution that could be used pan-India. In the second phase, we try to look at an initial process and mindset change that comes about. Initial processes, every state, every district have, and every jurisdictional officer has their way by which a process is tweaked and operated. The idea is there are a lot of good processes that would have been coming about in each of these places, and there are some process changes that can be done to make a structured, streamlined way and lean operations that can be brought about. To go about it, we need to have a mindset change to both unlearn and learn a lot of new processes that are there, which are right now data driven systems approach towards the whole problem. So a significant amount of orientation with uh, alpha level app that could be used in terms of the technology, in terms of data collection, and some amount of understanding and deeper understanding about the interventions. So we are at present traveling in this step. The next leap will be to ensure that we could have standardized SOPs that are put in place across the system. So the process capability will be in building standard SOPs and also have a larger pool of skilled stakeholder across the states. Uh, then if we are able to achieve it, we reach the iRAD goal. For all nominal purposes, we could look at it as even reaching the SDG goal of 50% reduction in fatalities or the number of persons killed. So this is the broad theme in which iRAD project would be traversing and improving. So initially 6 states, Tamil Nadu, Karnataka, Madhya Pradesh, Maharashtra, Uttar Pradesh and Rajasthan are part of the pilot states in which the process goes. So from the pilot states, pick some lighthouse districts where we bring the change, and they become the people who can have a, as they call the snowball effect. So it will start small, go big. This is a simplified representation of the data architecture of iRAD as a database, how it would be working. There is a part who will be a data contributor, and then there is a part who will be data consumers in terms of what they would want to do. The data contribution starts with an accident. The first responders, be it the cops, the uh, emergency responders in terms of the health, or even general public, could pick up and initiate a ticket where they collect very critical pivotal information of where is the location of the accident, what are the videographic, photo or audio recordings that can describe the accidents in a better way, and also nominally put out what is the severity of the accident in terms of the injuries and other things that are there. Obviously, the general public reporting and initiating a ticket is a more complex phenomenon. It would come at a later stage. But in the initial stages of the iRAD, the ticket is initiated by the police, and it could be subsequently added by the health responders who visit the site first, so they could also start. Once the ticket is started here, an alert is issued to the 4 contributing department. The police are very critical in terms of adding significant amount of information, and they are also the people who can collate all the information and form a final structure to it. The health department does everything with reference to the human involved in the accident in terms of their medical legal certificates, as well as other accident severity indicators. If there is no MLC required, the health and trauma people can add on information into the ticket. The transport talks about the machine related issues that needs to be addressed, and the highways talks about the infrastructure. So the three key aspects, the human, machine and the infrastructure, are done by the respective departments, and it is all collated and put in a final format by the police team that will be involved. That way, a proper full accident information is put together. There could be a dashboard that the responsible government officials can take up and use it. There are other analytics tools that will be built into the system where the jurisdictional person can pick up, whether it is at a station level or at a district level or at a range level or a commissionerate, whichever level they are looking at. The different departments could take mechanisms by which they can build small analytics so that they can use it for their interventions that they are planning, as well as the senior leadership can have a mechanism by which they can have a monitoring and compliance that can be there, and also useful as an educational tool that is there. So this is in a nutshell what iRAD will be doing when it is fully operational very soon. Philosophically, what was introduced when we were looking at the process flow change. The traditional process flow involves making notes and then trying to put it together and subsequently mount it to the databases that are there. From this depends on the skill of the person who makes the observation. You get a good Sherlock Holmes, probably makes good observation and good analysis after. Since Sherlock Holmes is one person, we look at it as how do we make sure that we have a structured data collection, and this iRAD can be then used by the IO to make a call. In IO, the investigation officer can make a call in terms of what needs to be done and how they take it forward. So putting it together as a single slide, there is a collision that happens. The police comes on the scene. There's a lot of things that is done, and then they try to get details from other departments like the MLC or the road related, and then load it onto an database, and then give their FIR and the investigation opinion. This is what is the job of an IO that is there in the current process. It is great, but it expects a lot from a single person to be an expert in multiple area, which is uh, which is a very good thing to have an expert in everything. But it is going to be very expensive to create such experts, and it will be even more expensive to ensure that the expert is working in a system which is going to be helping him to get all the information at a speed at which he doesn't get uh, dissuaded to perform the activity at the optimal level of performance. What we proposed is, once the collision happens, the first police on the scene is usually a constable or a person who is a young person. So what if we even take a recruit level, lowest constable, ranked constable into the area, but we give him a good structured fact-finding mission, and then you have a system by which all the stakeholders are piling up into the same pipe by adding their data. So once this pipe is filled with all the data that is there, the IO can then examine the information that is brought in, interpret the information much better so that he has a good investigation report that can be filed. So the database is also good, and he is also able to make a good interpretation of what the accident is and the interventions that come about later. So that philosophy to execute it in terms of technology, what needs to be done, it's a collaborative effort between IIT Madras, NIXI and MORTH to bring iRAD into the countrywide deployment at the earliest possible. And the idea here is IIT Madras does we brought that thought process, design and architecture that we brought in. And constantly we will be helping in terms of analytics, working with the governments and the agencies to start thinking higher, like what kind of analysis that can be done, what kind of interpretation that can be done, and what kind of implementation and the pathway for implementation. It is easy to think about a solution, it's harder to implement such a solution. So how do we bring in best practices from across the spectrum and go about making the analysis as well as implementing them. So that in building the strategy and working all with the different departments will be within the scope of what IIT Madras will be there, design and analytics to implement. And NIXI is the agency which develops the architecture into a functional system for the database to be maintained, as well as some of the simpler analytics that can be done on a call, as well as maintaining the data integrity and improving the system with the technology progress so that it can be readily available across the country at all points of time without any outages. Uh, at present, we have trained the lighthouse districts, and the lighthouse districts are oriented and they have the thought process gone. So there is some amount of customization and bringing in various knowledge that is there within the different states, different districts. Try to bring standard SOPs are there, and the next big jump in terms of trying to bring a mechanism by which things are to be done. So good thing about this program is the government took an initiative and said that they will be having uh, an individual who is going to be supporting the data collection in each of the districts. They would also be the TOTs for new people, because there is a constant rotation of officers across departments. So they would be available at a district level, pan India, to train and keep them functional and the data integrity to be monitored. And IIT Madras will continue to train them on the concept and take it forward in terms of it. Nick will continue helping these TOTs to make sure that they are constantly at the top performance for tech support. Coming to the roles played by various agencies and the governments post deployment, uh, the national coordination will be done by Ministry of Road Transport and Highways. The national highways, which contribute to a large percentage of road fatality, will continue to work using the iRAD system with the individual state governments jurisdiction. The part of the highways are, so that it can be improved, address black spots on their roads, and MOT will act as an information repository of the iRAD system. Individual states will be responsible for the data compliance, planning their own interventions, implementing them, and assess an impact, what it is, and more importantly, share the best practices at a national level. Because we have used the state of Tamil Nadu here just to say that individual states, because we were starting with the TN model, but it will be all the states who will be doing the same activity. IIT Madras will continue to advise both MOTH and other states on interventions that could be developed, how to improve capability and capacity, perform audits, death audits, which could help understand the success stories as well as areas of improvement, and work on data analytics for other purposes. NIXI will continue to maintain the softwares, have a support structure in each of the districts to help them, making sure that good quality data is available, do the appropriate data cleaning so that the data is maintained at a high level, and work on continuous improvement to bring technology for better purpose in the road safety. With this, I would like to thank you from IIT Madras, Gajendra Circle. If you have any questions, please feel free to write to the email address listed here, or to me in person. Do visit our website and share your thoughts on them. Thank you for taking your time to understand iRAD.